or maybe I'm
Okay. Okay, I'm going to actually, recap. Thank you, Dr.
Yeah.
I'm going to just recap the things I actually mentioned.
Uh-huh.
He mentioned about the discipline when you were like listening to the video, right? He said accessible, make something accessible. Like, how many of you use iPhone app? iPhone, right? And how many of the built-in iPhone apps have you really never touched? I've never used actually. There are a lot of built-in apps. It's too simplistic. Some of the apps like game your video, and there are like a lot of examples I can give, which makes it accessible. Like you want to do something, what you want to do, the mapping from the thought to actual doing it is the gap is like almost zero. That's what is accessible means, making that user experience, right? And he also said he was talking about learning, how we go about learning about the problem domain. I'll be speaking about the problem domain, solution domain, how the focus shifts from analysis to design and so on later. But I just want to mention this entire thing he was talking about was about learning. The TDD process, when you're doing TDD, it's basically a learning process. You're learning a new domain, you're learning a new API, you're learning something new from, you're pair programming with somebody else, you're learning something new from the other guy. You know, he's showing you new tricks, he's showing him your stuff and stuff like that. And then he was also talking about how the human mind thinks. You go step by step thinking, right? You can't really overload your brain with too many things at once. And that's what happens, right? When you're developing software, you're given a problem, you have to analyze the existing problem first. You need to understand the existing problem. Can you give me an example? Example is something he was talking about. You give me a problem statement, or can you give me an example? Okay, there is an example. There is an example. I gradually increase my understanding of the system, and then I make the examples executable. That's what it really is. It's one way to look at it. Like executable specs or executable examples. If you R spec shows you, okay, this many specs was ran, this many passed, this many failed, so you know exactly, you know, if you run through format it in a right documentation format, it shows you, like it gives you a list of things to look at, and it's kind of like a laundry list of things that's available in the system, like executable documentation, right? And yes, basically it's a learning process, and you going through the, he showed you the multiple representations. You go to an interview, and the interviewer gives you a problem statement, and it's all in textual thing. There can be more ambiguity, but what if that's not your primary strength? If you're a visual kind of a person, then you convert that problem statement to a visual thing, like you showed you ties, this, that. If you're an algebraic equation kind of a guy, you do the algebraic equation and you solve from it. If I give you a factorial, I can give you a definition of what the factorial is actually. Or I can give you just the factorial, like a mathematical representation of what factorial is, or Fibonacci is. And then whatever representation is your strong point, if I don't give you in your strong point, and if you give in a weaker representation, you need to be able to translate to your stronger representation and solve it, right? Write your code, basically, right? So that's the problem solving aspect of it. So he went through one example of beanie tie, and he going showing from the visual to the algebraic equation. That's what eventually is going to end up in your code, right? So the overall theme of his entire presentation was the simplicity, right? Being able to simplify. The external world is so cluttered, and it is so many things are chaotic, and keeping everything simple. The representation that you keep inside is always simple. So whatever you solve, whatever the solution comes with, is always simple. So simplicity overall is applicable to our TDD, because basically when you use TDD, it's a tool to build a system that is minimalistic, right? To minimize waste. That's one of the concepts in XP where we don't want to waste our resources. We don't want to have waste. Waste in the form of having a feature nobody uses, right? It's a waste of developers' time, money, resources, everything, right? So let me just move on to the my presentation. And before I give you the structure, how this thing is going to be, I have like 7 different topics I'll be going through, and they have several subtopics. I'll be showing you as I'm going through them. But before that, I want to get this 3 learning levels out of the way. And let me see if anyway, I was trying to see if I can not mirror this. That's fine. So basically, you have 3 learning levels. First is the beginner stage, like you were saying, Shika was saying, I just do a copy paste. I really don't understand. You don't really know why you're doing certain things, but you're just reading some book, aspect book or something else, and you just do it. It just works, but you really don't know why you're doing things. That's the level 1, right? And then the next level is you really understand, okay, why you're doing things this way versus you're able to make decisions based on what the circumstances, the constraints, whatever you have. You're able to make the right choice given alternatives. You have a lot of choice because you know different ways of solving the problem and different ways of actually resolving issues, but you can choose the right one based on situation, right? That's the second level. Third level is you're not actually bounded by any of the rules and the guidelines and all this. The beginners are given all these things, right? If you want to learn how to do TDD, I'm going to go over them. Testing guidelines, this is what you do. Here is the TDD cycle, here is the TDD rhythm, and this is what you should do, this is what you should avoid from doing, and observing other developers doing all these things. But sometimes, once you know why we actually have those guidelines and rules and all those things, it's just like kind of like a training wheels. Once you get used to it, the third level is like you are able to improvise. You can keep all those things constant and you can actually improvise because you know what the goals are, right? So I'll be going over the goals of what the TDD is and how we actually attain those goals, okay? So let's first get this classic versus Marxist, all this debate out of the way before we even show you the structure of the presentation. In classic TDD, basically, if you watch Ken Beck programming, you will see that he never uses any mock objects, no stubs, no marks, nothing. He always uses real objects, okay? And it's the way that he goes about is it's inside-out development. He starts with the domain model and he gradually, start with one thing and then it's depending on something else and he keeps going and then he hits some layer, next layer of your system, the next, and then now outermost the boundary of your system, and then you actually eventually complete the entire system. That's the classic way of doing TDD. Now the BDD and all those different things now it has come up. Now we have stubs, you have mocks, you have all the different things, and I am a classic TDD. I'm a BDD. TDD is great. BDD is great. I don't want to actually get into the argument, but I'm going to show you what is state verification, what is behavior verification, and I'll just leave it to you. And I can give you certain guidelines as to when certain thing is applicable. To me, eventually what the ultimate guideline for choosing whether the classic TDD or the Marxist approach is something has to make, if the tool makes it simple, simplicity is a guideline for me to make the choice. I don't want to get into this camp or that camp, right? If it makes my life simple, it makes my code simple, simplicity is the ultimate thing that I actually aim for, okay? And I'll show you all the different approaches, and it's up to you to decide whether, you want to combine them both, or you consider yourself as a classic TDD or a Marxist, or you want to be a BDD, like all this behavior-driven thing going on, okay? So this is the structure for our today's bootcamp. So simplicity, first thing that we saw was how to make complex things simple. I'm going to tie in the things that he talked about as it relates to TDD. So I'll be spending some time on simplicity. And then we need to know what the goals of our test automation is. Whenever somebody's talking about aspect, oh, this is so great, and TDD, BDD, it's all about what? It's all about design. But there is more than just, that's not the only goal. That's the primary goal, yes, I totally agree. But there are 3 more goals related to test automation, and that really actually helps us in a lot of, as I was talking before, like 2 days, 3 days of debugging, we want to avoid them, having a way to have a regression test. And there are other goals that we need to be aware of, and when we work on our project, we want to be able to accomplish those goals as well, okay? And then we'll see the basics of TDD. And this is the TDD cycle, the red-green refactor, and how you go through the cycle. That cycle it keeps repeating. That becomes a rhythm. Okay, that has some subtopics on it that I will be showing you which subtopic we are as I cover those topics. And I found there are certain concepts which is applicable to both test code as well as the production code. So I just grouped them together into intersecting concepts. There are some minor differences, like separation of concerns when it relates to testing, which is a little bit different, that I'll be discussing them, okay? And then the basics of testing. This is when we will see how to write tests. We'll spend a lot of time on different problem solving techniques while we are actually writing the test at the micro level. What are the different problem solving techniques? And at the macro level, outside in, inside out, those kind of different ways of actually testing your system. Okay, and then designing for testability. Actually, the design itself is it could be a 1 day worth of content, but I have just I'm just covering certain things, trying to hit the important points there as it relates to testing. And the effective test automation, I'll be going over some roadmap, how we can actually, when you consider the entire system, it's kind of like simplicity. The first topic is the big picture of what we are actually going to go over, and then gradually we'll zoom in to nitty-gritty details of how you structure your test, what is the first test you should write, what is the next test you should write, and then you zoom back into the, designing for testability is more like system design. You go back up to the entire system, effective test automation, and then you look at big picture, okay? So we basically go from big picture, we zoom in, and then we go back, zoom out, and see how they all relate to each other. So the first thing I'm going to be discussing is the simplicity. So what is simplicity? When somebody says simplicity, what comes to your mind? There is no clutter. So here's one definition of simplicity. This sounds more like it's the Pareto principle, right? 80-20 rule, right? If you spend it 20%, you get 80% of your output. That's your maximizing your stuff. And here is another definition of simplicity. So you emphasize what is essential, right? And you eliminate all the unnecessary stuff. And anybody know what this is? It's a Japanese bento. It's a lunch box, okay? And if you see there are like different colors, it's well balanced. It's like nutritious. It gives you all the different things that you need, that your body needs. And each and everything in this box, there is no waste. You can eat everything, except the box perhaps, okay? So there is no waste. Okay, and it provides nutrition. Obviously, we need, right? In software, you need utility. It needs to provide utility for you guys. And there is so many. It's not like a word, Word Perfect or something from Microsoft, which you have all the features that nobody else uses, right? There is so much waste. There is so many things that's not really required. So, and here is simplicity. This is simple and elegant. This is a Wakasa, the Japanese umbrella. And this is simple and elegant. It's very complex and difficult to create. It actually requires 4 or 5 different people with specialized skills to produce this umbrella. Okay? And simplicity doesn't mean that something which is very simplistic, right? If you just keep on watering down something, everything should be made simple as possible, but not simpler. If you just make something more and more simpler, eventually it will lose its value. If it does not have utility, then it becomes simplistic. It's not simple, actually it becomes simplistic. But simplicity is the ultimate sophistication. So how can you achieve this thing? If customer is asking you for this, and you give this, that's the 37 signals definition of simplicity. Sneakers only cost $2, whereas the previous one cost like thousands of dollars. But that's like sophisticated chocolate. This one is like $2. You know what, customer, you can have sneakers, even though you ask something else. This is not simplicity. So what is simplicity and what is simplistic? Simplistic is based on ignorance, whereas simplicity is based on awareness. And simplistic is inattention. Simplicity is about knowledge. And simplistic is about laziness, whereas simplicity is about spirit of helping. Deception versus honesty and sincerity. And the ultimate guideline. Simplicity is easy for us. Satisfaction signal says, hey customer, you can have the sneaker. It's because it's easy for me to create the sneaker instead of giving you that sophisticated chocolate that's handmade. But easy for customers is what simplicity is about. Whether from a user experience perspective, somebody designs the architecture, if it makes the developers easy, I give you an API or a Twitter API. Does it make life easy, or is it like authorized.net API, which makes everything complicated, right? We have seen software like that, right? So when it comes to software, simplicity, everybody gives their own definition of simplicity. And it's kind of elusive, something we strive for. But when it comes to software, we need something concrete, right? So this is taken from XP guy, I can't remember his name. So he has come up with this terminology, so I will be just briefly going over them, So what is this T? T stands for testable, right? If you write your test first and if you make a design testable, you eventually end up with a system that is highly coupled, loosely coupled and highly cohesive, okay? This allows you to achieve simplicity and understandable. This is obvious. Understandable to not just a developer at your level. You are like a really advanced Ruby developer and you're doing all this crazy meta programming, but is it understandable for somebody who is coming in to work as an intern, for instance? Right? Browseable is, you need to be able to find what you're looking for when you need it. Right? If you don't have this kind of quality in your software, basically you'll be wasting your own time while maintaining the software. New requirements come in, changes needs to be made, and even you don't know where to find the code that you wrote a few weeks ago. You're basically going to spend a lot of time on things you don't really like. You could be working on some other cool things, right? Explainable, that's what understandable is obvious, but explainable is something to others. How accessible is this? Like the professor was saying, right? Can you make it accessible to somebody else? Not at your level. Can you make it understandable to a child, at your mom? That simplicity, that characteristic in your software. Can you make it, self-explanatory? So those are the qualities. And when it comes to software, only thing I can think of, without giving rack is like if it's a framework from a coding perspective, looking at the software, it's very accessible. It's not like Rails. Rails source code, I don't understand a single line of code in Rails source code. I can download this rack and I can actually read this code. It's accessible to me. It achieves simplicity. The API has simplicity. It's not simplistic. It provides value. A lot of developers use it to make it run on several different web servers. All the Ruby web frameworks comply to this rack. And it's continually, it's like progressing, like several different versions coming out. I think the latest one is like 1.4. So it has utility, it has its simplicity, it has no bloat at all. It's like the bento box of software. You use everything or you don't use anything at all from this rack spec. And it's focused on doing one thing and it does it really well. After rack, I would say Sinatra to some extent. Sinatra, it exposes complexity. So if you want to deal with complex things, you need to actually start writing complex things. So the only thing that is going to be constant while you're developing is this change. That's the only thing that we can be guaranteed for tomorrow, right? You just finish the feature and you come in tomorrow, either that feature is going to change, or they've just decided to scrap that entire thing altogether, you need to throw it out, or you need to modify it, you need to do a major surgery. But to do this change, XP allows, one of the values of XP is being able to make this change. The entire process is about adapting to the change because our environment changes. Software actually interacts with the environment, and the environment acts upon the software. So we need to respond to the change. But we are afraid to change it. How many of you have actually gone and changed the code? Suddenly another guy comes and says, okay, you change the code, my stuff is broken. So mine is not working because of the change that you made is not already applied. Now your responsibility is to fix this issue, right? Impact of changes. You always have that fear. What am I going to break? The existing thing, if it does not have any test coverage, you're always afraid to make any changes. So the TDD allows you to deal with change because it reduces the fear of making changes. If you have a set of tests and okay, I can catch them if I actually break something when I modify, you can actually go and fix it. And then you don't check in anything until all the test passes. And also it allows you to focus at two different levels. At a macro level, a CEO says, okay, for this quarter we have these themes. We want this, like phrases, 3 or 4 phrases. He has a laundry list of 3 items, let's say, for this quarter. That's all we can get through for this quarter release. And what do you do for the weekly? You break down those themes into stories, right? And then when you get down to code on a daily basis, what do you do to those stories? Then eventually you're going to have a class, and then you're going to have, it should do this, it should do this. You have a bunch of tests, right? It allows you to focus at the macro level and at the micro level. So that covers the simplicity. There's a lot of things about simplicity, but how do you know you have really accomplished, you have achieved simplicity? It's kind of like really difficult to pinpoint, okay, this has achieved simplicity. To some extent, you can say, okay, this has certain characteristics that is found in other system that has achieved simplicity. Okay. Now we are going to look at the goals of test automation, which I think is really important before you even dive into it, because we should know what we're aiming for by automating all these things, right? So the goal number 1 is specification, and the focus is the design. This is what you hear from a lot of people actually. Oh, RSpec is great, and it's not really about testing, it's about design. Yes, the primary goal is design, I totally agree. And you specify how the system should behave, okay? And then goal number 2 is also documentation, okay? I went through the tube, right? Explainable, browsable. The browsable relates to this. I need to be able to see, I need to find something, where do I need to go to find what I need to find? For this particular scenario, how does the system behave? So it provides me, the focus is documentation, so that I always have up-to-date documentation. I always can answer questions to the marketing team if they come and say, okay, is this thing already done, or do we need to actually, add in a new requirement that needs to be developed. And goal number 3 is safety net. Okay, it's like it provides a safety net. You need this to make progress. Without the safety net, you're back to square one. It's just finger pointing at each other is finger pointing at everybody else. You made the change, the code broke. So you need to have regression. Then when a bug comes in, ideally you need to write a test to expose the regression bug. You fix it, and not only that, now we have a test to cover that kind of a thing. But you also need to start thinking about where else in the system can something similar can happen. So that way you reduce the holes in your safety net. Okay, so you have a better regressions test. Okay, So you can accomplish, you can always make your safety net a little more stronger whenever these bugs comes into your queue. Okay, then the next is number 4 is, like you said, only thing that's constant in the software, just guaranteed to happen, is change. Change is coming, it's guaranteed. So how are you going to make your maintenance easier? So all this maintenance can be easy on yourself so that you can work on cool stuff instead of just getting stuck on trying to debug existing thing, and trying to modify existing code base, right? So we have all these 4 different goals, and some of these goals are, for instance, the documentation. When you want some documentation, you want the documentation to be very, very clear to read, right? And how do you write documentation which is going to be clear? Is it going to be concise versus something clear? There is there is a force. Something which is concise can become really very cryptic, and you can't really understand what's going on there, right? Always keep this in mind. So documentation is more important than having something really concise, right? Especially when other developers are going to maintain your code. So the first goal I said is specification. Now let's see what is this specification actually. What does it mean to specify something? Actually, Ken Beck said specification is the goal of TDD, not validation. Validation is the side effect of doing TDD. Okay, we're not really trying to write exhaustive amount of tests. Okay, Ken Beck actually there was one simple programming problem involving triangles. Okay, Ken Beck wrote like 8 or 10 tests, but the guy who was like a QA guy, Robert Bender, wrote 65 tests. Okay, so when do you stop? Okay, it's not about validation. It's about specification. It's about driving the design of my code. Okay, developer's intent. While you're doing TDD, you try to drive the design of your code. And when I have enough confidence in my code, okay, I have a safety net which I think, things which are more likely to happen, I've handled it, you just stop writing tests. It's not like, like writing 65 tests for a simplistic problem. Right? Okay, here is an example of a specification. So this is a design of a car. And just by looking at this, what kind of things can what can you say about this specification? What is it actually trying to tell you?
Just kind of the size of shapes.
Yes, I can answer the question, what is the height? For instance, it is giving me this. What is this entire overall, length of this? Okay, from bumper to bumper, from this to this. What is the height inside? Okay, somebody who is 6 feet, can they fit in here? I can answer what? What is the height of the internal passenger seat? What is the width? What is the height? What is the distance between these things? What? It's all about what? This specification is all about what? What is the distance between this and this? It does not emphasize how the engine is going to actually operate, or how much power is going to be in the transmission. It does not say anything about how the transmission is going to be auto, it's going to be a manual. It does not say any of those implementation details. It's all about specification, only about specification. It gives you only specification. Those are the only thing I can answer here. So this is how the customer explained it, and the project leader understood it this way. How the analyst designed it, how the programmer wrote it, how the business consultant described it. Documentation doesn't exist. That's one of the goals, but there is no documentation here. It's missing totally. And what operations installed? Nothing. And the customer charged like this, as if the train bed or something. how it was supported. Virtually nothing. Marketing advertises is a lovely swing, focusing on this. What the customer really needed was this. The open source version is tagged $0 and it has all these bells and whistles here. So how do you, whatever the customer is saying, either giving you the behavior of the system, how are you going to specify the behavior of the system? How are you going to document the system? How are you going to support it? Okay? How are you going to meet the business needs, right? So we have all these different goals that we need to achieve. You have to specify things so that you don't lose the message, right? Now let's, I just briefly mentioned about the problem solving things while I discuss about the simplicities. I just want to go over this thing quickly. So somebody gives you a problem. The first thing you do is like, okay, I don't know what this Fibonacci is. I've never heard this thing before. So first you need to look at the problem domain. So when you're doing this, you're actually focused on the problem domain. And then the solution domain is the solution system actually. That's going to be the actual algebraic equation or something which is going to actually define. It's a well-defined, it's kind of a specification. It's not like, there is no ambiguity in the language there, okay? To end up like what we saw in the previous slide. This is a solved problem, okay? And when you're in the problem domain, you're basically in the analysis. You're analyzing the problem. I'm trying to understand the problem. You give me a problem statement. Okay, can you give me an example? I write down the example. Okay, can you give me another example? I write down another example. And I keep going, all the different boundary cases and stuff. Okay, I understand enough about the problem. I've done enough analysis. Now I need to solve the problem. I can cheat. I can look up Google, whatever. Eventually, I need to solve the problem. That's the design aspect of it. So your mind is actually, if you focus on one thing, you should focus on one thing. If you're doing analysis, make sure you're analyzing and understanding the problem correctly. And then when you're going to the solution domain, make sure your design or your solution to the problem is going to address all the different cases. That's going to answer when you start writing your executable samples, okay? There is this intersection between these two. This is the specification, actually, that's going to connect the problem domain to the solution domain. That's what is going to address the requirements, okay? That's what the specification is. There's a lot of confusion between what the specification is. There was even a keyword specifying in RSpec, actually. Specify behavior, but you're actually bridging this problem domain, solution domain. So again, I just covering the primary goal, specification. What is this really? How can we design? Design is in the solution domain, solution space. Okay, specification is actually bridging from the analysis, from your analysis to the design. Okay. Analysis as such, you don't do too much of upfront analysis. To some extent, you do just enough to actually start writing some tests to give you that momentum initially, okay? So that covers, now we know what the goals of test automation are. Okay, it's not just the design. Yes, it's a primary goal, but we do have other goals like we saw, okay? That's going to help to maintain documentation and all that stuff. Now we are going to go to the basics of TDD. So this is divided into different subsections. So first we will see the TDD cycle, and then we will see how this TDD cycle repeats itself over and over again. That becomes the rhythm of TDD. When you're sitting with a pair and you're coding, how that's going to actually work and all that, okay? And then that's lower level, micro level, and then we're going to go back up and see kickstarting the TDD cycle. Big picture, actually, the entire system as such, okay? And maintaining the TDD cycle in the context of a project, okay? So let's look at the TDD cycle. This is just one cycle. No repetition or anything, okay? Everybody must have heard this thing before, right? You're failing in a test, make the test pass, refactor. So you're in red state, make the test pass is green, refactor it should be in green. Okay. There are 3 simple rules when you are doing this. Write no production code except to pass a failing test. Okay. So this is very simple thing, but if you're not very disciplined, you will start writing code, production code that is not really required to pass the test, or you don't have a test first that demands you to write more code. Okay. Write only enough of a test to demonstrate a failure. If you're just too enthusiastic, I have all these different things, I'm going to handle everything in one test. No, just focus on again, it's about focus. Test one thing and one thing only. Each test should test one thing and one thing only. Focus. Write only enough production code to pass the test. Not too much, just enough. Just enough to pass the existing test. Your test should force writing more production code. Okay? These are simple rules, but if you're not aware, you could violate them and you're not doing TDD anymore. And it's something else. And you will get into problems and you're stuck and you don't know how to get this cycle going and you cannot establish a rhythm, the TDD rhythm. Once you get into the hang of TDD rhythm, then it'll become part of your behavior. You just apply them without even thinking. Okay. So write a failing test, and we already saw one of our goal is to be able to actually maintain the software, right? Always add in another thing. Always make the diagnostics clear. How can you make your diagnostics clear? I expected this, I got this. And make sure you specify what the expected value was, give the assertion message, okay, and then this is what you actually got. So when you actually go in, look at the error message, can you immediately go and fix the problem? Or are you going to be like spending a lot of hours? If the test does not provide the value of being able to pinpoint, okay, this is where I need to go and fix, there is no point in having a test. You're back to square one again. Debugging for like 2 days, 3 days just to figure out what the problem is. And you don't know what the problem is. If you're in a situation where your test doesn't tell you where the problem is, there is no value in having a test. So you have to make the test that you did, you make your diagnostic clear for yourself and for others. Make the test pass, refactor. Always improve the diagnostics of your own test. How many libraries, APIs, gems have you used, and the error message it gives, the user doesn't really know what they need to do to recover from the error message. What is the point? There's no value in that kind of a thing. Okay, so let's first look at the test first programming. We want to write the test first, not after the fact the code has been written. If you already have written a code, if you write a test, you'll be green already. It won't fail. And your code will actually dictate what your test structure should be. And if your code is shitty, then your test will also be shitty, right? And both will be really difficult to maintain, right? And you want to write the test first so that you're designing a system that is testable, so that you achieve this, highly cohesive, loosely coupled system. Okay. This is how the traffic light works. Green, yellow, red. Green, yellow, red. Okay. So we are going from green to yellow. Okay. And then yellow to red. And then red to green. These are the traffic transitions. Okay, let's look at them in detail now. Going from green to yellow. Yellow, see, the red-green refactor is actually kind of like a misnomer. Red, green. Refactor is not a name of a color. Doesn't make any sense to me. So, in order to actually understand, okay, what are the right things to do and what things you need to avoid, this was done by one of the XP guys, so I have taken those thing from his blog post. So basically, it goes from green to yellow. Yellow is basically you made a syntax error. You're not failing for the right reason. If you're failing for the right reason, that's a red. Okay. Green is all tests are passing. Okay. So let's take the first condition. If you're going from green to yellow, all the tests were passing. That's what green means. Now you add a new test, but you're yellow, which means you made a syntax error. You need to correct the syntax error, so it'll fail for the right reason, and then you can go back. Okay, so that's okay. If you make a syntax error, just correct it. You can keep going. Going from yellow to red, you just made you corrected the syntax error. Now the test is failing for the right reason. That's fine. And then when you have going from red to green, what it means is once you have a failing test for the right reason, you go and write the production code just enough to pass that particular test. Okay, minimal, always minimal. Okay, minimalistic system. Simplicity is what we are aiming for. Okay, so the test now passes. That is fine. Okay. Let's consider the other scenario where you have a blinking green. Green, blinking green. Okay, you're green and you're green. So you have, let's say you have like 10 tests running. It's all green, and you see some code duplication in all your tests. You clean up. You're going to be green. Or it could also mean, in that case, it's okay. Or it could also mean you wrote a test, it passed, but the bug is in your test. Okay, the system does not really satisfy the behavior, but the test that you wrote is not correct. So it's saying green. In that case, green to green. In that case, feature is complete. You can also think of it as if your test is buggy, there is no test to prove the correctness of your test. Okay, that's one thing. And it's just like a false negative basically when the test is actually not testing anything and the system is saying, okay, it's already implemented something. You basically have to fix the bugs in the bug in your test so that it fails. Okay. Another scenario where the green can happen is, let's say I give you a factorial, for instance, and you're so familiar with the factorial, you just write the very first test, the abstract thing, it just handles all the thing. Because your dominant learning mode is like algebraic equation, and you knew this thing well, that okay, this you just type in the Office implementation. Okay, next one I give you the boundary condition. The test is not going to fail because that abstract solution already handles the boundary condition. Okay, so you go from green to green. In this case, what should you do? Because remember, you don't have a test to test your test. How will you prove the correctness of your test? Because it's not becoming red, right? So you go to your production code and break the boundary condition. For the boundary condition, you return some other invalid value so that it breaks for the right reason. Only by knowing the test failure, I know it's actually testing the right thing I'm expecting it to test, right? If the test doesn't fail, it's a feedback basically. If the test doesn't fail, then it's an indication of, okay, something is wrong, I need to do something. Okay, always we need to have a failing test because the test does not have another test to prove its correctness. Only way we test the test is manually by checking, okay, it's failing for the right reason. Is this failing for the right reason? You do it once manually and that's it, right? Test is bad. We already saw that test could be buggy, so that you need to fix the test actually. The code may be okay. Okay. Now we saw how you go mutate. In the production code, you break it for the boundary condition, so the test fails, and you can actually make the test fail. It go from red to green. And we also saw when you were refactoring, you have a lot of tests. You see a lot of duplication. You pull a lot of things into your setup. And you clean up all your thing, and you may use using a lead block and all that. So you always refactor when you're green, and when you're ending the refactoring, you should be green. Okay, this concept is so simple, but people actually miss this. I know this is I'm red right now, but I know this is a very simple change I'm going to make. I know it's going to work. You make the change, but it still doesn't work. You're red. I'm refactoring. You cannot refactor when you're in red right now. You can never refactor when you're in red. You should always start your refactor when you're in green. When you finish your refactor, you should be green. Okay. Again, it's all about the focus. If you read the refactoring book by Martin Fowler, he says either you add a new feature or you either refactor. You don't do both at the same time. Either you clean up the code or you add a new feature. Do one or the other. Don't do both at the same time. But the concept is so simple, yet people don't focus. They just try to do multiple things. You're adding a new feature and at the same time you're refactoring. Don't do that. Because it's about having the discipline, right? Having that focus, being able to focus one thing at a time. Okay, never ever refactor when you're in red state. So if you have like a flashing yellow, what does it mean? Yellow is what? Yellow stands for? You just made some syntax error. You just correct the syntax error. So yellow, blinking yellow, you just correct your syntax error. Either the test passes or it fails for the right reason, so that you're back to the one of the state where you can go to make the progress for the next state. Okay, what about this red? Blinking red. The blinking yellow is like a traffic light. You slow down and if something is happening, you cannot proceed further unless you fix your syntax error. Blinking red in a traffic light, you actually stop and look, right? This color is all about feedback. It's giving you feedback. Red, you're being in red. Red is flashing. You added a test. It's breaking. You did something in the production code to make it pass. It's still red. You're red for a long time. Our objective is always to go from the red to green very, very quickly. If you're red for too long, you're doing something wrong. You're taking much bigger steps than you really need to. You're overconfident. Okay? And there are exceptions. Like if you're upgrading the Rails or RSpec in your project, you will be in red for a long time, 1-2 hours. You'll be in red. You cannot avoid it. But I've seen situations where you add a ton of code and a developer is so confident, he can make it work, but it's not working. You have several different alternatives to solve a problem. You take one approach, okay? That approach is not working. So you need to back out to the previous state. If you check in often, whenever you're green and you accomplish certain level of features, you can actually go back to that state and take an alternative path and you can try a new thing, right? You don't know if this is going to work, okay? You're analyzing a certain alternative to that particular problem. The problem domain, you understood the problem. Your solution is being tested, whether it's going to work or not. If it's not working, you need to back out and try a different solution, okay? So it's a way for you to actually, these blinks always indicate that you have to stop and do something different. It breaks the TDD cycle. When it's all green, you have to go and mutate the production code, or you have to think what exactly is the context of this green flashing or yellow flashing is straightforward. You just fix the syntax and move on. Whereas this red, you need to think about more. Okay, I need to roll back, do a git checkout. Let's go back. I don't think this is going to work out. Maybe I'm pair programming with TOEFL, and he's telling, okay, maybe you're right. Well, let's try your alternative solution and see if that will work. Okay. Now let's consider the reverse direction of how the traffic light flows. So in this case, I go from green to red, and then red to yellow, and then yellow to green, okay? So what does it mean going from green to red? All the tests were passing, you added in a new test, and you're red. Can we say it's okay? If you're failing for the right reason, it's okay. And you are you're failing for the right reason, but you now have a syntax error. What happened right now? Think about this one. What do you do when you have a failing test? You have to write your production code. You made a syntax error in your production code. Fix that syntax error in your production code. Maybe your configuration is missing. You did something, you need to fix that. So to get past it, you need to do something there. And then going from yellow to green, you basically fix the syntax error. Either you'll go to red or something. If you fix that error, when you're in production code, you fix the syntax error, then it passes. That's also fine, right? So I want to really emphasize this thing, because when you're failing for the right reason, you want to get to green very, very quickly. I always want this feedback loop. I want very quick feedback. Whatever I'm doing, is this working? Is this working? Okay. Write a failing test. Your focus is on what the system should do. That's your only focus in the problem domain. That circle, okay? You focus on the what aspect of it, okay? That's when this red state is happening, okay? And the green is when you're trying to make it pass. That's when you're actually worried about, okay, is my solution is going to work? Now you're worried about design. The red was about analysis and specifying, whereas the green was about making something work. And if you keep on cleaning up, refactoring, you can stay in green as long as you want. But you want to minimize this thing. You want to minimize the time you are in red. Okay? So to reiterate it from a different perspective, write a failing unit test. That's how we started right. What should my system do? We will fly over some golden clouds and at this particular speed, and this is what I expect this thing to behave. You want to write a failing test. Start with a failing test. Start it right. Okay? You make it work. When you make it work, you are evil-minded actually. You just want to write the minimal amount of code, the lazy way of minimal amount of code in your production to get the existing test working. You want to make it work, but you're really evil-minded actually. You don't want to do more work than is really required, that is demanded. And then you make it right. Now you need to clean up. Just because it's working, it doesn't mean your design is good. You need to actually make sure you don't have any duplication and you're applying the good design principles, and your code is clean. Okay, make it right. And then you can worry about making it fast. Okay, you have a recursive solution, it was in production, and your boss comes and says, this is not performing well. Then you need to worry about make it fast. Change the algorithm. Now you have a suite of tests. So you can change, even if you change the algorithm, you can actually make sure you don't break anything. And then later you can worry about making something really pretty, all the UI, this, that, Because the previous steps allows you to, okay, how does this alternative evaluate versus another alternative? You take different alternatives, different routes, one of them works out, everything works fine. So that's the TDD cycle, okay? Now what is this rhythm of TDD? The TDD cycle is going to repeat. It's just not going to stop just because you wrote one failing test and you made it pass. Again, you have to write another failing test, pass. It's going to keep repeating over and over again, okay? So rhythm of TDD. I already explained at the micro level and the macro level how we actually break down the themes and the stories into a laundry list of things you need to actually write and get it working. When you're doing this and you're working with a pairing partner, it's like ping pong. It's called ping pong basically. I write a test, you make it pass. And then you write a test, I make it pass. And then we keep going like this, okay? It established kind of like a rhythm, okay? And sometimes you're familiar with regular expression, and I'm not. That could break the rhythm. You know what? I will let you drive since you know regular expression. I'm going to just write the test for it, and he's going to implement it. So it depends. The pair programming, it's a learning process. He knows something, I know something. We learn from each other. It's a learning process. Again, we saw how often do you check in? When do you check in? It affects the rhythm, right? If you're in red for too long, your rhythm is broken. Red, green, refactor, red, green, refactor, red, green, refactor, red, green, refactor. Established rhythm. If you're red, that's broken. Your rhythm is broken. You don't want to break your rhythm. If you get to a point where you have sufficient functionality, you check in as often as you think, okay, it's one atomic function, I'm going to check it in right now. So what does it allow you to do? Two different paths. You take one path, you end up in red, you need to come back to that fork again. So you can try a different solution. If you already checked in the code, you can always go back to a working green version and try an alternative version of Gabriel. Okay, he knows better than me. Okay, I'll use this algorithm, right? Okay, that's the rhythm of TDD. Okay, now we are going to actually zoom up and look at the big picture. Kickstarting the TDD cycle. Okay, you go into a project and it's just not like the very first time you go and start writing code, it's not like as if you can start writing unit tests right away, right? You need to maybe interact with the external web services, you have some messaging thing, and maybe you need to interact with the legacy system, you have existing database that you need to interact with. So it's like an overall system. Somebody comes up with an architecture. So the very first thing you do is you test a walking skeleton. That's what is called as a walking skeleton. It doesn't do much. It's okay. I can actually talk to a database. I can put a hello message into the messaging queue. I can say hello to Twitter. I can do insert some dummy records into the legacy database or something. I can talk to a legacy. The entire thing, the very first iteration is called iteration 0. It doesn't do anything. It's skeleton. You just are able to establish, okay, I can do all the different things. That's all you focus on. You're fleshing out those technical details, configuration thing, and all the different things. Okay, in testing sandbags, okay, if it's a PayPal or we're having the different accounts, you're doing all the different things, right? That needs to be done. How do you maintain the TDD cycle? It's just giving you need to be able to listen to your tests. How do you listen to your tests? It's not going to play music like this, but the pain, you may be having a pain in writing a test, and that pain is actually trying to tell you something. It's trying to tell you something, but are you able to listen to your tests? It's saying that your design, that it needs improvement. There is something that needs to be done to improve the design. Initially I asked what makes TDD difficult, okay? Writing test itself is difficult. That itself is like it's trying to tell you something. It's a symptom of your bad design. Somebody else came up with, so you have to actually, how are you going to deal with this design, right? Long setup code duplication, all kinds of different things, but you always have to look for the structure of your tests and see what it's trying to tell you. And not just like you start writing test 1, 2, 3, 4, and you just keep, you're just so at this you're focused on just only the one test at a time, and you need to be able to actually zoom out and be able to see how does the previous test relate to the test I'm going to write now. How does it fit into the big picture? Because sometimes the test that you write, you may just delete it. It was just a way to actually get to another test, which actually it's much more appropriate, and you would retain that test. Sometimes you had to delete the test. It's not longer applicable anymore. So I will be going over when you actually delete tests, which scenarios you'll be deleting tests. So you always need to know how does the existing test fit into the overall scenario, and how are you listening to the feedback that the tests are giving you. So that's the maintaining the TDD cycle, being able to listen to the tests, and actually consciously you need to apply good design principles, right? Magically, if you're just using TDD, you cannot say, okay, great design emerged out of this. It's emergent design, it just happened to me. Might happen if Ken Peck is coding, you have like 3 decades of experience, but we have to consciously listen to this, the feedback the tests are giving, the structure that's emerging, and we need to consciously apply good design principles. That's the maintaining the TDD cycle. So that completes the basics of TDD, and I'm just going to go over this some of the concepts which is like common to both testing and the production code. Probably we will once I complete this, we will stop for lunch break if you want. It's almost like 12, and then we will work on a simple Fibonacci TDD thing, so that you get used to the TDD cycle, work in pairs, okay? So what are these intersecting concepts, which is a concept which is applicable to both? Yeah, bugs, right? It's whenever you say bug, you just think of, okay, only the production code can have bug. No. Actually, the test can have bugs. So you need to be aware of that, so you can avoid them. I'll be giving you some guidelines of how we can avoid them. So what is this bugs? How can they happen? And it's impossible, right? That's what when you have like a false negative, the test is passing when it's supposed to fail. That is a bug right there. And false positive, test is failing when it's supposed to pass. So when you're using stubs and marks, let's say Shika is on one team and I'm working on another team, and I'm actually marking out whatever, because I mark only what I belong. We are in the same company. I'm going to use whatever the API we agreed upon. I'm using that mark, it's passing, okay? And she went and changed the interface. My mark passes. It says, hey, fine, because I'm using a mark. Whereas the real object in the real production will fail. So that's a false positive. Now my test has a bug in it. Right? So I need to update the test. And if you have an integration test, it will catch that integration problems. Okay? So I will be giving you the guidelines on how we can actually getting into the situation where you have like bugs in your code. Okay. One thing I really want to emphasize is your test, your automated test, does not have a test to prove its correctness. So what it means is you have to keep your test so simple, it does not require a test. Okay. Simplicity again. And the maintenance cost. If you keep it simple, if it's documented, if you can quickly go and fix the, it's called defect localization. When something breaks, exactly it breaks because of just one thing. It should break only one test when one thing goes wrong. Otherwise, like hundreds of tests fails. I don't know why. What exactly needs to be fixed. So defect localization is important to prevent high maintenance costs. If it's something is giving you good diagnostics, okay, I expected this, I got this, I know exactly where to go and fix, it's easy for me to maintain. It lowers the maintenance costs. Again, ties back into the goal that we have, right? Code duplication. Everybody here knows how to actually recognize the code duplication and refactor and clean up your test code or your production code. But the thing is, being able to actually the data duplication, is also important. Data duplication also is a form of duplication that you need to be aware. Don't use like magic numbers like 5, 10. What does it signify? What 5? Okay, it's a premium customer, is charge something, specify that. Make it as a constant, declare it at one place, So data duplication is also, you need to focus on, even in your tests, you need to make sure you define them, and it's intention revealing, expressive, names for the methods, constants that you're using, classes. So hard to test code. So one of the things I asked was what makes testing difficult? What is some examples of hard to test code? How about threading, transactions, GUI components? And there are so many things to make testing difficult. You don't want to make testing difficult yourself by writing really code which is complex. You want to keep everything simple, okay? You want to minimize complexity in your actual test, okay? Communicate intent. So just don't just name your variables are like A, B, C. What does that variable signify? Or just T, a temp, even if it's not a temp variable. Just it has to have intention revealing names, variable names, constant names, method names, the class names. When you communicate intent, you're communicating with yourself in the future. If you want to maintain later, you need to know what you were actually thinking when you actually wrote this code. Otherwise, again, ties back into the maintenance cost. That particular goal we had. The same thing is applicable for the production code also. I want to treat the test code just like I would do the production code. I want to have expressive tests. I want to specify things. I want to only say what. I want to hide all the implementation details of how I'm going to do certain things. I want this thing to be expressive. It's kind of like telling a story. Separation of concerns, right? Same thing here. Just like in production code, if you have a well-designed system, you have a layered architecture where the different concerns are all separated. In test code also, I want to have separation of concerns. In the sense, I want to, if I'm testing a specific thing about logging or something, I want to only focus on that particular thing. I don't want to test 5 different things, make 5 different assertions on things which are unrelated. So it's a little bit different in that sense, from production code. Separation of concerns is more like, you're focused, and clarity, it's more about clarity. Yeah, just keep your test very simple, because we don't have another test to prove the correctness. And how can you improve quality? All the things that we saw before, keeping making it expressive, keeping it simple, being able to actually see where exactly things are broken, defect localization, so I can quickly go and fix it. It also improves the quality of your test code itself, having no code duplication, no data duplication. All the changes are localized. You just go to one spot and you just change stuff there, so that you don't have to, go to so many different places to change things. Makes your maintenance easier. You don't have that complexity, basically. It should be easy to write and maintain. Frameworks like RSpec makes it easy to write and maintain. They give you a lot of built-in assertions that if you're familiar, you can just use them. You just specify what your system should do. And it's already tested. Those assertion messages are already tested. For your particular domain, you may want to write your own utilities and stuff, but you still need to test those utilities. Should have separate tests, so that you treat that as like an external library. So you can make sure that's well tested before you start using your domain-specific, things. So those are the intersecting concepts between testing and coding. Now I think I'm going to stop here because right now we have like 4 sections, and then basics of testing. We'll see how to write tests and all that when we come back from lunch. So designing for testability, effective test automation, and then we'll be working on a TDD kata and stuff. Okay. So any questions so far?
I'm wondering when you describe these concepts, can you show some code examples? Because just by showing the heading and then talking about it, it doesn't. I mean, it's not.
Yes, I have a lot of code samples when I actually cover the steps, marks, and stuff like that. And this TDD cycle, I'm going to give you that Fibonacci factorial and things, and I'll be actually going around. See, that's more like it's what you do is daily. You know, the things that you go through. You know, if you're like working for 8 hours, you're doing TDD. The kind of things you are aware of, and the kind of things you actually do, is like more like a decision-making process. What you focus on, you know, how you write the test, what test to write first. Conceptually, you need to know, you know, how do you pick the first test to write? You know, am I doing the right thing? What is the next test to pick, for instance? And if you have once you have a series of tests, how do you maintain the existing growing test suite? Those are the things which will actually help you not, you know, yes, having code can illustrate some concepts, definitely. I will be having some sample code, and also I'm going to let you work on some things, and I will be actually helping you. It's not about the actual problem itself. I want to focus more on, I can even give you the equation, right? Solve problem. Okay, this is a problem, this is a solution to make, this is a solved problem. I want you to focus more on the red-green refactor and how the thing, you know, feels when you're working in a pair. And some of the things like the goals, like documentation and stuff like that, it's kind of, I just showed you rack as an example for, you know, I would say, you know, to me that's embodies simplicity. You know, you just have to do a git clone and start reading reading the code. So if I have time, I can do all that. I think you have a good point, but in the interest of time, I actually want to see how much material I can get through, and we can actually go back and look at some code samples really to illustrate those concepts.
Right, so if we do focus on the concepts, if you have examples, it'll be easier to
understand. I think,
right,
yeah, it's very
said,
abstract.
For example, you mentioned data, duplicate data.
Code duplication, everybody knows. 100% everybody can do. Data duplication,
so
yes.
How do you test it?
Like for instance, I can give you an example. For instance, you're using, let's say, one of the recent project I was working on, okay, they were using -1 for a record, a primary key, okay. They're using -1 or 0 because what is the significance of -1 or 0? The record is not there. When the record is not found, I want the behavioral system to be this way, versus when it does find, it does something else. So if you just use the magic number like -1 and 0 in your code everywhere, it's all over the place, and you would rather have a constant defined as illegal primary key equals -1. That's it. You just say illegal primary key. It signifies, okay, that's what the meaning you're attaching to it, to that thing, 0 or -1.
I think
what I meant is, if you could show us an example how you use TDD to find such problems. I understand magic numbers.
Because now you've seen the problem.
I see the problem. How do you test it?
Yeah.
Right, that's what I mean.
Yeah.
That we have to work on a problem to see, you know. The test, see, when you start writing 1 test, 2, 3, and then once you reach the 3rd test, you start recognizing certain duplication. See, the cleanup code, make it right, start it right, write a failing test, make it pass, and then you refactor. Refactor is the state when you actually recognize the duplication. You clean up, your time for a cleanup. So you have to actually, the best way to actually do it. That's why I just want to, give you the exercise, and once you start identifying what the duplication are, you are going to be cleaning up those things, you know. So you have to actually do it in order to
So it's not
get more.
something that you could detect through TDD test
T-
cases, but
yes.
more like something that you find out during refactoring?
Yes, you can actually see how it emerges. You know, you're going to look for the pattern that as it emerges as you code. So let's work on that factorial or something. If you guys want to start working on it right now, it's only going to take like half an hour. Okay? It's up to you guys.